A man pushes a heavy box across the floor. He exerts a force of 80 Newton and the box moves 4 meters in 5 seconds. So what useful power does the man develop? We can use the formula. Power is equal to work done over time. And the work done can be calculated by force times distance. So the force will be 80 Newton times 4 meters. So that will give us 80 times 4 divided by the time taken of 5 seconds. And this will work out to be 64 watt. So the answer should be B. The diagram shows a mercury barometer, and a barometer is used to measure the atmospheric pressure. And how it measures the atmospheric pressure, right? It works by the principle that this column of mercury is equivalent to the atmospheric pressure. So the atmospheric pressure is equal to the pressure exerted by this height h of the mercury column. Okay, so in short, the higher the atmospheric pressure, the higher the value of h here. Okay, so now what happens to the distance h when the mercury barometer is taken up in a balloon? Okay, as the altitude increases, the layer of air becomes thinner, so the atmospheric pressure will decrease. So when the atmospheric pressure decreases, this will cause the height of this mercury column to decrease as well. So the answer should be B. The distance h decreases because the atmospheric pressure decreases with height. Okay, we have a brick of weight 80 Newton that is standing upright as shown. So what is the pressure that it exerts on the ground? With this we can calculate the pressure as force over area. So the area in contact with the ground, it will be this area, and this area is equal to 10 cm times 5 cm. And the force is actually the gravitational force of the brick, which is the weight. So it will be 80 divided by 10 times 5. The answer should be C. Okay, when fine pollen grains are suspended in water, they are seen to be making small erratic movement under a microscope. Okay, what is the reason for this, right? The pollen grain, by right, they should not be moving on their own. The reason why they are moving in this manner is because they are constantly being hit by the water molecules that are moving in random motion. Okay, so the answer should be B. Okay, before we attempt this question, right, let us recall that pressure is the force acting per unit area. So pressure is proportional to the force, which is the force of the air molecules on the walls of the cylinder. And what will affect the force acted by the gas molecule on the cylinder? There are two factors. Number one is the speed of collision, and number two is the frequency of collision. Okay, so now we can look at the question. Okay, we have the gas inside the cylinder heated slowly to a higher temperature. Higher temperature means that now the gas molecules, they have higher Ke, and that means that the speed increases as well. Okay, so now the pressure inside the cylinder remains constant as the piston moves outwards. Okay, now how do the speed of the gas molecule and their rate of collision with the piston compare with the initial value at the lower temperature? Okay, let's look at the speed of molecules. Since the gas is now at a higher temperature, the speed must be higher. So, speed of molecules must be greater. Okay, now the keyword here, right, for the second part, it says that the pressure inside the cylinder remains constant as the piston moves outwards. So, the speed of molecule has already increased and it caused an increase in the pressure. So to bring it back to the pressure, the initial pressure value, right, the frequency of collision must decrease to compensate for the increase in pressure caused by the speed. Okay, so the rate of collision here, it has to be reduced. So the answer should be B.